Okay, so in this video, we're still on the data part of the 2018 Further Maths Exam 1. So we're up to question 10 now. And so in this study, association between a person's height and the body surface area is, from a least squares line was obtained. So this is the equation we're talking about here. Okay. And what the questions are from A to E here is it's knowing what is meant by this equation, or basically an equation that is y equals a plus bx. It's that format, and so it's knowing how to understand what this means, what that means, what having the x there means, stuff like that. Okay, so in saying that, the first, I'm going to rule out one straight away, and that's C. C is, it's saying the correlation coefficient is 0.019. One, you don't have any information that would give you a correlation coefficient, plus that value is the gradient. Okay? That is the B value there. All right? Increase in 1 meter squared of the surface area, 1 meter squared, is associated with an increase in that much height. If I'm looking at that, that's not going to be that much height that's increasing. Okay, so in case, I'm going to rule out that again. A person's body surface area here in square centimeters can be determined by adding 1.1 centimeters to the height. No, because that's one you're subtracting it, but you've also got this part here. It's not going to work. Okay. So it's D out, and E, a person's height in centimeters can be determined by subtracting 1.1 from their body surface area. And again, I've got a height, I'm multiplying it by number. They're saying subtract that from this value here, and I'll get their height. Again, not going to work. So when we look at this, what we can say is, that was a process of elimination to work out B. You don't have to take that long to do it, but I was just showing you what's going on there. What we've got here, an increase of 1 centimeter in height. So 1 centimeter in height is associated with an increase in that, in body surface area. Because you're always going to start with that, but if I have that, it's 1 times 0.019. So I'm going to increase the body surface area by 0.019 for 1 centimeter. So in that case, that is B. So question 11. Freya used the following data to generate the scatter plot below. So we've got a scatter plot. That gives us a nice curved graph, which, as we can see, is nonlinear. All right. Now, to linearize the data, Freya applies a reciprocal transformation that's important to the variable y. And the reason that's important is going to be here. She then fits a least squares line to the transformed data. So with x as the explanatory variable, the equation of the least squares line is closest to. We know that y has to be in that form, because that's what we've done. We've done a reciprocal transformation. That means D and E is out like that. Okay? Now, here comes the hardest part for this question, because now you've got to work out which A, B, or C is going to be the answer. All right, the easiest way to look at this one here is to pick the two points. I'm going to say pick the first point and the last point. Probably could be really any of them, but I just find those ones are the two easiest for me. So I'm picking these two. All right. So my x is staying the same, and my two x's are staying the same. So that means, in a sense, I'm going to look at the gradient. I'm looking at seeing if I can match up which one of those it's going to be, because that's going to be my easiest thing. So basically, if you're going to do a rise over run, so basically the gradient is going to be the rise, which we haven't got because we're going to work that out. And the run, well, it's basically 10 minus 1. So that's going to be 9. Let's actually just write that in there. And we'll come back to the next bit in a moment. So basically what's happening is this value here, I'm going to go 1 divided by 105. And then this, I'm going to go 1 divided by 9. So 1 divided by 105 is going to give me a value of, so it's going to give us a value of 0.009. For these purposes, I'm going to go 0, 1. Okay? So if you think about if you're redrawing this graph, at the moment, I'm going to be down like here is, if that's 0, and so that's 0 and that's 10, so my 1 is going to be some really small number there. Okay? It's like saying 1, 0.01. Okay? Now, that's for this point here. And then I'm going to do the other point up at 10. Okay? And that's going to be 1 divided by 9. 1 divided by 9 will give you 0.1111. So that's like saying 10. And my y is going to be 0.111. All right. Okay. So as we can see, we've got our two y values. So in this case, what I'm going to do, and so when I do this, I'm going to give me an exact answer, but it's going to be close enough. So I'm going to say that I've got 0.1 minus 0.01. I'm going to divide that by 9, and basically I get an answer of 0.01, which again, that's not an exact, because I've, in this case, these two values here, I've actually, I've got the, I can't think of the right words at the moment, but I haven't got the full numbers. If you did the proper numbers, you're going to get the full answer. But the point of showing that is that the closest, it clearly rubs out that one, because what it should be here is 1, 2. So that's what I mean, it's close. It gives you an idea it's A, and you think, oh, it could be C, but when you have a look at this means that the y-axis would be the y-intercept will be 7.8. It's clearly not going to be 7.8, so it can't be that. So the answer is going to be A. But I would just focus on that. In this case, you're going for reasonably close. If you're doing on your CAS, you could probably you could just get the numbers and put those in, and it would give you a more accurate answer than the 0.01 I got. But it gives you a close enough value. Okay. All right. I'm going to finish this video there, and then I'll move on to the next set of questions. Thank you.